Today we will start with for, looping with for. But since we are starting with lesson 13, let's get the example scripts of lesson 13 first. So I'm on the directory examples. Let me get with wget https linux cli.fs.al examples lesson 13.tgz. Actually, let us extract it. Lesson 13.tgz. And let's go to the directory lesson 13. So we will start with looping with for. Let's write a simple for loop for I in A, B, C, D, E, F, do echo I, and then done. So this is a variable. We have named it I, and it is going to take the values in this list. It is a space separated list. So it will get first the first value, and then we'll execute the body of the loop, which is echo I, and then I will get the next value in the list, or the next word. We can think of this as words since they are separated by spaces, and then we'll execute the body of the loop, and so on. Now we can write this in a more compact way, or which is nicer. A dot dot F, and it is exactly the same. It gives the same result. And if you remember this A dot dot F in curly braces, it is a shell expansion, and shell is expanding this one exactly to this. And so this for is exactly the same as this one, but it is more convenient to write, and it looks nicer. And we can use other shell expansions like this. For example, for I in star.sh, do echo I. And now this is expanded by the shell to be replaced with all the files in the current directory which match this expression. So the files with sh extension. And for each file in the list, I will get that value, and then echo I will print it. But what happens, for example, if there is no match to this pattern? So there are no files with extension .text. In this case, shell cannot expand it, and it is left unexpanded. So I will take only this value as an argument, and the loop will be executed. The body of the loop will be executed only once, and it will print this one. In case that we want to protect against such a case, then we have to check whether the file I exists or not. For example, before doing an echo, I can write a test. -a exists. So the command of the body of the loop now becomes this one. Check if the file exists first. If it exists, then print it. So if file exists, print the name of the file. And because there is no file with such name, then this will not be printed. Now let's see an example which uses a for loop. This example. This is going to find the longest string in a file. And we have a while loop here, and then there is this if, and then there is another loop here, a for loop here. And why we are using two loops? Because we assume that this script can have more than one file name. So it can take a file name as an argument, and it is going to find the longest string in that file. But in case that we give 2 or 3 file names, then it is going to process all of them. And this while loop is going to take these files one by one. So it is checking the first argument. $1 is a special variable that contains the name, the value of the first argument. The first argument is the first file. If it is not empty, then it will execute this part. And after executing this part, this shift is going to drop the first argument, and then the second argument will become the first. So the second argument will be shifted to the first place and will become $1. And then the while will be repeated again with the second argument, and so on, until all the file names that are given to the script are processed. And before processing a file, we check whether it is readable, whether we can read the content of the file. So if the file is readable, then do these things. And we are going to find, we want to find the string, the longest string, or the longest word in the file. So we are using two variables, two auxiliary variables. Max word is the word with the maximum length, and maxlen is the maximum length that we have seen so far. We initialize the max word to empty, and then we also initialize the max length to 0, because we have not checked any words yet. Now this for is taking the words that come from this command, strings, and then the name of the file. What does this string do? It converts the content. It converts the content of a file into words, strings. For example, this file. But actually, we are using it like this, and let's say echo. So we see that we have a list of all the words in the file, and if I say for I in this list of words, for I in this list of words, do echo I, done, then it is going to take all the words one by one, and in this case it is printing each word. But in the string we are not interested in printing them, but we want to check to get the length of the word. And so this I is one of the words in the file, and we find the length of the word with this command, echo, and then word count minus C. This minus C is for characters. This word count is counting the number of words, characters, or lines. In this case, we are counting how many characters are in the standard are coming from the standard input, and we store it in the variable len. Now, if len is equal to max len, then we have found the word that is longer than the words that we have seen previously. So we keep this length into variable max len, and then we also keep the max word, the maximum word, the word that we are processing into this variable max word. And we do this for all the words in the file. At the end of the for loop, we will have the length, the word with the maximum length in this variable, and the maximum length will be in this variable, and we are just printing them. So for this file, because this $1 is the file that we are processing, max word is the maximum word, and max len characters is the maximum number of characters. So let us try this script. Dot longest word dot sh. It does not print anything because it needs actually it needs a file. For example, I'm giving this file as an argument, and it says that in this file, this is the longest word, and it has 11 characters. Let's say that I'm giving several files. For example, and this one, and also this one. And it is processing each file. This is done by the while loop, and for each file, it is printing the results that it finds. So this is the longest word, 11 characters. In this file, this is the longest word. It contains 19 characters. So this is not actually a normal an English word, but it is considered a word because it does not have any spaces. So we separate words from each other by a space. And in this file, this is the longest word, which is 25 characters long. And we can also do something like this, and the shell is going to replace this with all the files in the current directory that have this sh extension. And it is going to process all of them. Now, this script, longest word 2, is very similar to this one that we just checked, but with a small modification. And the modification is that instead of while, we are using a for to process all the arguments of the script. And when we process all the arguments of the script, we just say for I or any other variable, but in this case, we are using I. Maybe I could have used F, for example, for file, but it is just I. So when we say for I and nothing else, semicolon, and the for, then it is going to process all the positional arguments, $1, $2, $3, and so on. And in case of when we used while, we had also a shift here to move the arguments to the left so that we can process all of them. But in this case that we are using for, we don't need a shift. And the rest of the script is exactly the same, with the only exception that we are using this j variable now in the for loop. because the variable I is being used for something else. But the rest, the logic and the code is exactly the same. So let's try this one too. Longest word too. It works the same way. The loop for has also another form, which is similar to that of C and many other programming languages. Let's see an example for I equal to 0, I less than 10, for example, I increment I by 1, do echo I done. So if the variable of I of the for loop, if the variable of the for loop is a numeric variable, then we can use this double parenthesis expression. And in this case, we don't put a $sign in front of the variable name. And we include inside it the initialization of the variable, the test of the variable, the test of stopping the loop, and the increment. We increment the variable by 1. We place it in the same place. So it is similar to the for loop in the C language and in Java, etc. Now, in the previous lesson, we modified the program sysinfo. It is on lesson 12 in the previous lesson. I'm going to copy it here. So in this variable, we keep the file name. Maybe I can declare it inside main as well. Oops. So these variables are global. So I'm declaring them, or I'm using them inside main, but they can be used in other functions as well, in other functions, because they are global. This file name contains the name of the file that the output will be stored to, the output of this script. This prog name contains just the name of this script, but we are using this base name to get just the name and to drop the path in front of the script. And this interactive shows us whether the file name is going to be received interactively from the keyboard or it is going to be received as an argument. So interactive 0 means it will not be received from the keyboard. If interactive is equal to 1, it means that the name of the file will be typed from the keyboard. The script will ask for the name of the file during its execution. First, we process the arguments, and we are passing all the arguments to this function. And then we call the function output HTML page. Here at process arguments, we check, first of all, whether there is an argument. So this is the first argument. If it is not empty, then we run this case to check whether the argument matches this or this, if it matches this or this, or if it matches this or this. In case that the first argument is matching this one, then the second argument is the file name. In case the first argument is matching this one or this one, then we set interactive to 1. And later in the script, we are going to receive the name of the file interactively. And if the argument is age or -l, we are calling the function usage, which shows how to use the script. And here we have these 3 cases, how the script can be used. So it can be used with this -h or -help argument, or it can be used with this argument, -i or -minus interactive, or it can have the argument as an argument -f or -minus file, and then it is followed by a file name. But there is also another case of using the script. And this case is when we use the script without any arguments at all. So we just call prog name without arguments. And in this case, the report will be sent to the script will send the report to the standard output, which is the screen. And we call this function output HTML page from the main function. And first, it is checking whether interactive is equal to 1. If interactive is equal to 1, it means that we have used the option -i or minus interactive. And in this case, it is calling the function get file name interactively. And the function get file name interactively is here above. We have a while loop. It is an infinite loop because while true does not stop by itself. Inside we have a read to get the name of the output file, and we store it into the variable file name. If the file name exists, this is checking whether the file name exists. Then we are asking another question. File name exists. Do you want to override it or not? And we expect a reply or an answer, which is Y, N, or Q for quit. We get the answer into this variable, and with these cases, we check whether it is equal to Y. In this case, we just break the while loop. We want to override it. So we already have the file name into this variable. We are done. The function is done. So break will exit the while loop, and it will end the function because there is nothing below the while loop. There is nothing after it. If Q is pressed, then it displays the message program terminated, and then exits the script, exit the execution of the script. Anything else, which includes this N, no, we don't want to override. It has this instruction continue. Continue makes the execution to start at the beginning of the while loop. So continue will prevent it from reaching this break, and break will terminate the loop. And if this if is in the case that the file exists. So we get a file name, we check whether it exists or not. If it exists, then we ask, do you want to overwrite it or not? If it does not exist, then we come below the if. And it is this break which exits this while loop, because this is an infinite loop. Without a break, it will never exist. So it will never stop. So this break stops it, and the function is done, and we already have the file name into this variable. And now, after we get the file name interactively, if needed, if the option interactive is specified, we are checking whether the file name is empty or not. If the file name is not empty, then we write the output of the script and redirect it to this file name. But first we check whether the file name is writable. And we do it by making a touch and testing whether the file name exists. So if the directory is writable, then we should be able to create a file into this directory, and this file should exist. And in this case, we redirect the output of this function to this file. Otherwise, if we cannot create a file into the current directory, we echo this error message and exit with 1, which is error message. Now, if the file name if the file name is not empty. If the file name is empty, so there is no file into this variable, then we come to this case, else, and we write HTML page to the standard output. So this function actually writes something to the standard output. And this is the body of HTML. And we are using these variables here that we declare above, title and timestamp. But we are also calling these functions, report uptime, report disk space, and report home space. And these functions we have seen previously. They have a heading of second level heading, this H2, with the title of the section. And then we execute a command, and we include the output of the command into preformatted tag, HTML tag. Report disk space is similar, but we are using this other command to report the disk space. And report home space is making a distinction between two cases. It is checking the ID of the current user. If it is equal to 0, it means that it is the user root that is executing the script. And in this case, it is showing, or it is displaying the home space utilization for all the users. Otherwise, it is displaying the home space utilization only for the current user. And now, let me make some small modifications to this report home space, and to make it better with more information, etc. So first of all, I want to move this output part outside the if. For DD, paste, And let me remove these lines too. Now, I'm using a variable dirlist, which is a list of directories. It contains a list of directories, and the list of directories in the first case is this one, all the home directories for all the users. And in case the user is not the super user, the list of directories, dirlist, is pwd, which is the current working directory. And let me use also this variable username, which is all users for the first case. And in the second case, username is only the current user. It is the username of the current user. And since I'm using these two variables, let me declare them as local variables. So I'm using these two variables in the body of the function, and I want them to be local variables so that they are not accessible outside the function. Now, what else? Now let's go to the output part. And actually, let me delete this cut. Oops. And let me say home space utilization, but not all users, but username, the variable username. So the title of this section is home space utilization, and it is either all users or it is just the current user. But in both cases, we are using this variable username. And we have a list of directories into this variable dirlist. Actually, in the second case, this list contains just one directory. In the first case, it contains a list of all home directories, because this star is going to be expanded by the shell to all the subdirectories of this directory. So this is a list of directories. It may have one directory, or it may contain several directories. So we can write a loop in this list, dir list, and this, let's say D, for example, because it is a directory. So for D in dir list, or let's say dir, for dir in dir list, we are going to do something. What are you going to do? This is the end of the for loop. Done is the end of the for loop. And I'm using another variable, total files. And this variable is going to contain the number of all the files in this directory. And we can find the number of all the files in this way. With the command find in which directory? In the directory dir. What to find? Type F. So find all the files in this directory, and then we pipe this output to the command wcl to count all the files in the directory. And let's find also the total number of directories, total dir, and it is very similar to this one. Find in this directory dir. Dir is this variable of for, which is taking the directories in this list one by one. Now type D, which is a directory, find all the directories, and pipe this output to the command wcl to count all the lines. And this way we will have all the number of directories into this variable. And let's find also the size. And we can find the size with the command disk usage, du disk usage, hs. This h is human readable, and this s is a summary. And it is for the directory dir, but we want only the first field. Cut F1. Only the first field from this from the output of this command. And now that we have these variables, we can do some output. Now another header and the name of the directory. And then echo pre-formatted tag. Let's close it here. So this is a closing pre-formatted tag, and in between printf files size. Now, what is this format? This is the format of the string that is going to be printed, and I'm going to declare it before the loop. So let me declare it as local format, and it is %8s, and then %10s, and then %10s, and then a new line. This %s is a string, but with this number 8, it means that the length of this string is 8 characters. This one is a string of length 10 characters, and also another string of length 10 characters, and it is going to print also a new line at the end. So I declared it outside the loop because it is going to be repeated, and it is the same for all the steps of the loop. But we are not done because this is just the headers of the table of information. Let's print also this. Like separating the header. And also let's print here the first variable, the %s will be replaced by this one. The second %s will be replaced by this one, and the third one by this one. In the second case, it is the same format, but the first %s will be replaced by this one, the third one by this one. And now we are using these variables. Total files, not total dirs here. And then total files, and then total size. So in this format, which is this string, this will be replaced by the value of this variable. The second % will be replaced by the value of the second variable, and the third % will be replaced by the value of this variable. So let's give it a try. Yes, it is showing only for the current directory here. But let me try with sudo. No, it is again for, let me try sudo su, and now .sysinfo. Okay, now it is showing for all the users. Let me save this to sysinfo.html. And let me view the content of this HTML file. So this is system uptime. This is disk space utilization and home space utilization for all the users, because we executed it as a root. And then we have these sections for each user with a number of directories, number of files, and size. Probably there is something wrong here because everything is empty. It seems to be okay. Anyway, so we are done with improving this script. no more improvements. We will continue with other topics, and the next topic is variable expansions in Bash. Let me exit here. Let's say that I have this variable a, which has the value foo. Now, we have seen this previously as well, but let's see it again. If I write this, now what happens is that the shell is considering this one as the variable name, because this is a valid character for a variable name, for a name. And this variable is undefined, so the output is empty. But if I write it like this, now this delimit what is the name of the variable. So it is the variable a, and its value is foo, and then it is appended. This string is appended to the value of the variable. So in case that it is not clear what is the variable name, we can use this curly braces to delimit the name of the variable. And let's see default values if the variable is unset. So the variable foo is empty, or I may unset it with unset foo. It is almost the same thing. Now, if I say echo now, if the variable unset, this operator is making the value of the variable this one. So we are trying to get the value of this variable, but it is empty or it is unset. In this case, this value will be used as a substitution. But let's say the variable foo has some value. And now I try this again. And now I get the value of the variable. So if the variable has some value, this expression will give the value of the variable. But if the variable is empty or unset, then this is like a default value for the variable. So this value will be used instead of empty string. And let's unset this variable again, and let's make a modification here. Now we have another kind of assignment. Now this is different from the first one because not only we get this value if the variable is unset, but this becomes this value is assigned to the variable also. So this value, the default value is assigned to the variable if it is empty or unset. In the first case, the variable is unset. We get this value instead, but the variable is still unset. It is still empty. But in this case, we are actually assigning this value to this variable. So and this assignment happens if this variable is empty. But if the variable has some value, for example, it has this value, and we try this again. Now we get the value of the variable. and this is not assigned to the variable. Now let's make the variable empty again, and let's try this. Now, if the variable is empty, then we get this as an error message, and also the exit code of the previous command, of this command, shows an error. But if the variable is not empty, and we try this, then we get the value of the variable, and the exit code. Let's try it again. The exit code is successful, shows a success. Now, another one. Now, this is the opposite of this operator. So this one is substituting the value if the variable is empty, but this one substitutes the value if the variable is not empty. So if the variable is empty, what we get from this expression is just empty. But if the variable is not empty, then the value of the variable is substituted by this value. So it does the opposite thing of this one. And let's see how to get the names of the variables that begin with a prefix. So if I type, for example, echo, this is replaced by all the names of the variables that start with bash. So these are all environment variables defined. They are already defined in the current environment, and we get the names of all the variables that start with bash. And if we try this one, what we get? It is the same. It is exactly the same. So if we want to get all the names of the variables that start with a certain word, then we can use either this or this one. Now let's see some string operators in bash, or string operations. So first of all, let's get a string into this variable. And this if we put this hash in front of the variable name, we get the length of this variable, the length of this string. So this 19 is actually the number of characters in this string. And we can verify it with this WC minus C, and we get one more for the end of line, because this echo is introducing an end of line. And if we want to avoid it, no, it is n, minus n. Minus n is not going to append an end of line after the string. So with this one, we get the number of characters in the content of this variable, or the length of this variable, the length of the variable. Now, if we want to extract a part of the string, then let's try this. What happens is that we are getting from the fifth character up to the end of the string. So the fifth character is this one, and we get all the rest up to the end of the string. So with this one, we can get a substring, a part of the string. But let's say that we append this column and 6. Then we are getting just 6 characters. So from the fifth one, we get 6 characters, not up to the end of the string. There are 6 characters here. And let's say that we can also use indexing starting from the end. So if I say -5, then it will get the fifth character from the end. So actually, it is including this. So to make it more visible, so it is including this one, but it is lost by the echo. So it is getting this empty space as well. So it is starting from the fifth character, counting from the end and up to the end of the string. And now, why don't we do it like this? We don't do it like this because, as we have seen, this means something else in the bash. So because of ambiguity, we have to leave this space here before the index of the character. And let's say that we get 2 characters. So we start from the fifth character from the end, and then we get only 2 characters. So these are ways to get a substring from the content of a variable. Now let's see how to remove some part of the content of the variable. For example, let's say that foo is equal to this one. Now we can remove some parts from the beginning of the content of this variable with this hash, and then this is a pattern which is matched starting from the beginning. So it is going to match up to this one, and it is going to be removed. So this is deleting some part of the string starting from the beginning of the string. the string which is the content of this variable. Now, if I use a double hash instead, this makes this pattern greedy. Greedy means that it will not stop when it matches the first dot, but it will stop when it matches the last one. So it is going to match this dot, and then it will continue until it matches this one. And there is no other dot here, so this is the part that it is going to match. So this double hash makes the pattern greedy, trying to match as much as possible. And so it is going to remove this part and leave only this one. This one will remain. So this was removing or deleting parts of the string from the beginning. Now, if we use this percentage instead of hash, then we are going to delete some parts of the string matching from the end. And now this dot and star is going to match this part on the end of the string, and this is going to be deleted. And again, if I use a double percentage, it is going to match to make this pattern greedy, trying to match as much as possible. And then it is going to match this part, and this part will be deleted. Let's see also how to replace some parts of the string. Now, replacement is done like this. So it is going to match this part, and it will be replaced by this part. But notice that it is replacing only the first match, not the second one and the third one and so on. Only the first match. And if I use instead this double slash, then the matching will be applied everywhere. So the replacement will be done on the first match, on the second match, and on the third match. So everything will be, all the matches will be replaced. And let's say that I do this percentage, then only the last match will be replaced. So only the last match of the string will be replaced. And if I use this hash in front of the pattern, in front of this pattern, then you guess that only the first match will be replaced. And what happens if I leave empty the replacement part? For example, this is replacing the first match with this one. But if the replacement is empty, then it is just removing it. It is just replacing it with nothing. And with this double slash, then it is replacing all the matches with nothing. And again, with this one, it will replace only the last match. And with this hash, it is going to replace only the first match. Now we have seen this longest word and longest word too, but let's see this first version of the string that finds the longest word in a file. It is very similar to longest word 2. The only difference is that where we get the length of the string. Let's make a diff to see clearly the difference. Diff longest word 2, longest word 3. Let's say we save it to this file. So the only difference is that this line has been changed by this one. So in the first script, we get the length of a word by making echo, and then we pass the output of this. We pipe the output of this command to wc -n, and here we get the length of the word using this hash in front of the name of the variable. So it makes the script smaller and easier to understand, but actually it makes it also faster, and we can verify that the second script is faster than the first one. So it is the improved script is performing faster. But first, let's get a long file to use as input for this script. So we are going to get the longest word in this file. And with the previous script, you see that it is taking longer. So the new version of the script is not only easier to read and nicer, it is also much faster. So it is getting a very long time to when the input is a big file, then it takes a lot of time to process it. And let's wait a couple of seconds until it is done. And we can actually time. We can get the time of execution of the command by using this command time. So time and then the script that is being executed. And we see that the real time is 0051 seconds. And for this script, for the old version of the script, let's see how much time it takes. So this real is all the time that the script has taken to execute. This is user time and system time. And here the script has taken almost 36 seconds, and the real time, including the system time, is 45 seconds. So this is much more efficient. And let's look at the diff file again. The reason why this is very efficient, this version is very efficient, is because this is a built-in feature of the bash, and it gets the length of the word immediately. But in this case, what happens? The bash sees this pipe character, and then it starts another shell to execute. It starts another shell to execute this command, and another shell to execute this command, and then connects these two shells through the pipes, so that the output of this shell or this command goes to the output to the input of this command. So starting this command many times has a performance penalty. In this case, no such thing is done. So that's why this one is much less efficient than this one. Very often, performance issues don't matter because scripts are small, but sometimes they may be important and they may matter. So let's start. Let's stop this lesson for today and continue on Friday.